before we do today's lesson, I need us to revise the laws of exponents. Who's going to go through the laws with me? Anyone? Raise your hand quickly so we can go through these chop chop and get to today's lesson. Nobody. Do we remember our laws? Why is nobody? Ha! Minenhle is like, Minenhle in the building. Hi, Minenhle. Oh, Minenhle unmuted mistakenly again. Hello.
Can I try, ma'am?
Yes, let's go for it.
So for the products, I think it's law 3.
Okay, well, it's law 1, but explain to me what it says.
So we times the exponent with the other exponents, ma'am. And we'll
remember, law number 1.
To the power of, ma'am.
So we have the same bases, right? You agree?
Yes, ma'am.
We have an
yes.
A and an A. And we are multiplying. That's where the word product comes from. If that happens, what do we do to the exponents?
It still stays A, ma'am.
Okay, we keep the base. That's true. And then what do we do to the exponents?
We times them with each other.
That is the power law. This is the product law. So we add. Do you remember?
Yes, ma'am. Sorry, ma'am.
There we go. Don't be sorry, girl. That's why we're doing revision. Okay.
It's boy, ma'am.
Oh boy, sorry. Sorry. Very nice voice, boy. It's fine. Okay. Let's go to quotient. Do you want to try quotient with me?
I can try, ma'am.
Let's go for it.
So we keep the base, but we minus the x and the y, ma'am.
We minus the exponent, but the condition is we have to be dividing. Do you see?
Oh, yes, ma'am.
So when we are dividing two values with the same base, we subtract the exponent. Okay, power law is the one you were talking about initially. You said if we have a power to a power, so we already have something to the power of x or raised to the power of y, then we
distribute.
Well, you distribute it, yes. So you're gonna give the y to the x, and then when it gets there, what do we do to them? We multiply them.
Times.
There we go. You see, that's the one you were talking about initially, nah?
Yes, ma'am.
There we go. And then the zero exponents, guys, I'm pretty sure everyone has crammed this one.
Equals 1.
Power of 0 is 1. And then we have our not so friendly law, the negative exponent law. What happens when we have a negative exponent?
We put it over 1 because any number can be over 1, ma'am. But in this situation, we just say 1 over the base, ma'am.
So we do the reciprocal. Thank you very,
welcome,
very much. Whew, that went quicker than I wanted it to go. So I'm happy. Okay. Don't laugh. The other class gave me a hard time, guys. I'm even sweating. The other class was just like, we're not here for you today. You will sweat today. Mr. Uyatandwa, welcome. Don't laugh at me, Liz. I'm going to laugh. You guys are laughing at me and it's not nice. Okay, what are we doing today? I'm kidding, guys. I'm full of jokes. Don't take me seriously. Exponential equations. In the chat, give me a thumbs up, thumbs down. Have we seen exponential equations before? Do we know what they are? Do we like them? Do we not like them so much, but we know them? Give me an indication with a thumbs up or a thumbs down. Okay, I see thumbs up in the reactions, about 7. Komzila says not a fan. Just was like, yeah. If I get it right, I like it. If I don't, I don't. Guys, I really used to like exponential equations. Why do so many people not like them? Hey, we have a love. Beautiful. Okay, it's fine. I think we're pretty split on this, right? Don't know what they are. You'll find out just now. But they are, right? They're part of the less hectic topics, if I dare to say that, guys. I'm afraid of saying that in math. You know, sometimes in math, you have it, and then you don't have it anymore. So I'm afraid of saying things are nice. But let's go for it, okay? So let's work with this that we have over here. Tell me in the chat, how would we work this out? So real. Exactly like what? What just happened? How people who have experienced exponential equations before, the answer is easy. It is a trap. No, it really is that easy. What you are thinking is the answer. Kenley? Not quite, Havana. You're getting some. Hello.
Ma'am, so we want our bases to be the same, so then we're gonna say 2 to the power of 2.
Wonderful. So we keep 2 to the power of x and we change 4 to 2 squared. Beautiful. Then what? What happens
And
after we do
then
that?
our bases are going to cancel, and then we're gonna have x equals 2.
Therefore, x equals 2. Thank you. Thank you so much. Okay.
You're welcome, ma'am.
Now, guys, let's explain what happened here. Okay, for those of you who've never seen this before, so we have a 2x equals 4. What do equations mean? Okay, equations are telling you that the right-hand side is equal to the left-hand side, okay? That's what an equation is. So we know that 2 to the exponent of something, that's what a variable is, right? Variable means something. We don't know what it is. So 2 to the exponent of something is equal to 2 to the exponent of 2. Now, guys, if we have the same bases, do you agree that we have the same base here? Our base is 2. Once we have that, then your exponents have to be equal. If 2 to the exponent of is the same as 2 to the exponent of 2, then whatever that was has to be 2. We can use the ladder to find your prime bases. Okay, good point, Tammy. Usually we like making these things to prime bases. There's also a very nice trick on your calculator, but I'm not sure if your teachers allow you to use calculators. But I'll tell you anyway. Okay, I'll tell you later when we need it. So guys, do you agree that if the bases are the same, exponents have to be equal? Because how else will you get 2 squared? X has to be 2. Okay, where's the other 2 coming from? Full fellow, which others? We have so many 2's here, I'm not sure. I think you're speaking about this one. Okay, we changed the 4. Remember we had a 4. We want the both sides to have the same base. Okay, now we already have a base of 2 on the left-hand side. Now we're going to change 4 into a product of its prime bases. Do you remember that? So you did the whole ladder stuff. Do you remember that? I hope you guys remember to do that ladder. It's very easy though. To tree your ladder, you say 4, then you start with 2, then you divide them, and they'll give you 2, then you do 2 again, and you divide them and give you 1. Therefore, 4 is the same as 2 squared. That's where it comes from, fellow. I hope I've answered your question. And then once they are the same base, we can equate the exponents. Okay, I think that was easy enough. Now let's try another one that's a little bit more interesting. I need someone else to help me with this one. Who's gonna help me with this one? Hands up. I like how I'm like hands up and not a single hand goes up. You guys are like, Guys, is Minenhle the only person in this class? Come on now. No offense, Minenhle, don't put your hand down. But I'm just saying, out of 130, only Minenhle wants to speak to me. Highly right. There we go, Tammy. Thank you very much for making me feel better. And CM Tanda. Hi, Tammy.
Hi, ma'am.
Let's do this together.
Okay, ma'am. So first, ma'am, you can use the ladder method to find the prime factors of 27. which is going to give you 3 to the power of 3.
Okay, we're gonna have to do it. So I keep this side. Exponent equals 3 to the power of 3. Wonderful. Now what?
Yes, ma'am. And then, ma'am, you can cancel out the bases, the 3 and the 3, and you can be left with x plus 1 equals to 3.
And then solve for x for me.
And then, ma'am, we're going to say x is equals to 3 minus 1, which is going to give you 2.
Therefore, x is 2. Thank you very much.
Pleasure,
May
ma'am.
the end be well. Thank you. Okay, guys, remember you make the whole exponent equal. Okay, so you cannot say x equals 3. What exponent did we have on the left? We had a x plus 1. So the whole x plus 1 has to equal 3. Okay. I don't like the term saying cancel the exponent, cancel the bases, but that's fine. Okay. So we have to make the whole, and then you test it. Okay. If x is 2, if you substitute x over there, substitute x, then you're going to have 3 to the exponent of 2 plus 1, which is the same as 3 to the exponent of 3, which is indeed 27. And our equation is correct. We have solved for x. Okay, I hope you are with me. All those people who said they don't like these or they've never seen them before, how are we feeling? This x is bothering me. You guys are going to have to bear with me so I can write another x that is nice. That's better. How are we feeling before we move on? Thumbs up, thumbs down. If you are lost, ask a question so we can solve it quick. Unam says thumbs up. Abisha, raise your hand so we can talk. Let's talk about it. We have 9 thumbs up. I see you guys in the reactions. Scrumptious. Whew. Aren't we fancy, sir? I feel like I should be drinking my tea now while reading that. We are doing scrumptious. Halalitang. Hello.
Hello, ma'am.
Did I lose you somewhere?
Ma'am, I just want to ask, how did we get 3 cubed?
3 cubed is the same as 27. So we have to put 27 as a product of its prime bases. Do you remember when you did that
Okay,
in
ma'am.
grade 8? So you have 27, right? So now you have
Yes,
to
ma'am.
divide it into products of its prime bases. So what are prime numbers? 2, 3, 5, 7. We can't use 2 because you can't divide 27 by 2, right?
Yes,
Do you
ma'am.
agree?
Yes, ma'am.
So we have to use 3. So 27 divided by 3 is how much?
It's 9.
9.
Yes,
Then we
ma'am.
can use 3 again. And 9 divided by 3 is how much?
It's 3.
3. And then we can use 3 again. And it will give you 1.
1.
So therefore, 27 is the same as 3 times 3 times 3. But we just rewrote that as 3 cubed. Do you see that? Okay. I hope Khanalitang is sort of there. Okay, someone asked, why do we subtract? We subtract because we are transposing, okay? The one was on the left-hand side over here, and we want to get rid of it. So it goes over to the right-hand side, but when it gets there, it becomes negative, and then we end up with 3 that was already there, minus 1, and that's where you get your answer is 2. Okay, it seems like we are keeping up, so I think we can move on. Ma'am, if it's 3 cubed, doesn't it have to be under the root? No, ma'am. If you root it, then you're going to say it's equal to 3, which is incorrect, right? 3 is not equal to 27. Doesn't have to be under the root. Cubed means to the exponent of 3. If you have a root, it means cube root. Okay, so we're not rooting here, we are cubing. C, who's doing C with me? C is a beautiful one. Eh? I love C. You're welcome. Who's doing C with me? Oh, I see a hand. Let me open it. Takawira. Hello.
Hello, ma'am.
You doing C with me?
Yeah, I am.
Let's go for it.
Okay, so I think it's going to be 4 to the power of 2 plus 2. No. I made a mistake, ma'am. Made a mistake. So what you're going to do is you're going to write 4x and then, okay, now I'm confused.
Okay, let's keep the space for now. Okay?
Yes, ma'am.
Equals. How can we rewrite 64 with a base of 4?
Oh, 4 to the power of, what's it now? 4 to the power of 3. And okay, so the x is meant to be a 1.
Yes. No, it isn't 1 actually. Remember, what do we have here? We don't have 4 to the power of 3. Right? We have 1 over 4 to the power of 3. Do you see that?
Yes.
We still
yes,
don't
ma'am.
have the same basis. So we want to put both sides to the same exponent. So we want 4. Now, which law is going to allow us to do that? Think of a law that's going to allow us to work backwards and have 4 to the power of something. In which law did we work with 1 over blah, 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 blah? Do you remember? Let's go back to our laws. There. Check this law here.
So is it I think it's going to be the negative exponent one.
There we go. So we are going to be working backwards. So we're going to make it negative. Do you see that?
Yes, okay, I see.
There we go. So it's going to be 4 to the power of negative 3. Now we have achieved what we wanted, which is the same base on both sides. We have a 4 there,
Yes.
and we have a 4 over there. Once we have the same
Yes, ma'am.
bases, what's the way forward?
Once we have the same bases, now we have to try get the powers to be the same.
So how do we do that? We say they're equal. If your bases are the
Yes.
same, then your exponents are the same. Do you agree?
Yes, I agree
So
with
we're
you,
going
ma'am.
to say x plus 2 is equal to what?
X plus 2 is equal to, isn't it going to be 2x?
The exponent on the right. So exponents on the left, which was x plus 2, is equal to exponents on the right, which is?
Oh, minus 3.
There we go. Negative
Oh, okay, so minus
3.
Okay.
Now we
have
just have a normal soft. And then we get rid of this 2. What happens when it goes over?
It's going to be like, it's going to be plusing. You're gonna minus on the other side.
There we go. So we're gonna have negative 3 minus 2. So your final answer for x is?
Minus, it's gonna be 1.
Check again. Negative 3 minus 2 is how much?
Minus 5.
There we go. Cool. Did you understand that?
Yes, I did, ma'am. Yeah, see, I saw where I went wrong.
Wonderful. That's beautiful. Okay, guys. I see you guys who had a 1 and negative 1 in the chat. Why did I zoom in? Did I zoom in, guys? Or did I just write bigger? I don't think I zoomed in. Okay, everyone who got negative 5, beautiful, wonderfully done. Everyone who's confused, raise your hand right now so we can talk about it and fix it. So the important thing to remember in this, guys, is that the laws work backwards. Okay, so we have our negative exponent law. So if you have a to the negative 2, you can make it the reciprocal, which will be 1 over a squared. Now in this case, we already have 1 over something, right? but we want both bases to be the same. So we want to fold this side and we want to fold this side. So we work backwards. We work that way. And we make it 4 to the power of a negative exponent. I saw a hand shoot up. Let's see. Shakira. I'll answer you just now, Butimelo. Shakira, do you have a question? No? Okay. Follow fellow.
Hello, ma'am.
Hello.
I wanted to ask about the one. Why is it that like when we got the one, we threw it away?
We didn't. Which one? Okay, wait, which one? Maybe I'm thinking
The
of
one,
something.
the one which was 1/4 to the power 3.
Oh, we didn't. Remember, we're doing the reciprocal. So if it was
Yes.
1/4 cubed, we make it 4 to the minus 3 over 1. But anything over 1 is just
The same.
the same. So that's why I didn't write it. Did you see?
Oh,
Did I answer your question?
yes. And also when we are adding and unlike terms, are we allowed to add them, or is it when we only multiply?
Only multiplication. We cannot add unlike terms, okay?
Oh, okay. Understand now. Thank you, ma'am.
There you go. You're welcome. Shakira says, can you do another one? Because I am lost. Okay, Shakira, we'll do plenty more. Okay, let's do a simple one on the side. Okay, the ones at the bottom, I can tell you, no, they are not simple. Let's start with the simple ones. Né? So if I say to you, 2 to the exponent of x is equal to 8. Okay, so I'm telling you step 1 is we want the same bases. Okay, so in the chat, tell me what base is that going to be? If all else fails, you just find the prime factors of 8. Good. So we're going to use the base of 2. So on the left, excuse me, we're going to keep our 2 to the x equals. If we want to find out the exponent of 2, if we want to 8, what is the exponent going to be? I know you guys can just figure it out. It's Tammy, step by step. Now, people are lost because we are skipping steps. There we go. So it has to be 3. So everyone who's like, how did you get that? Remember 2 times 2 times 2 will give you 8. And 2 times 2 times 2 is the same as 2 cubed. Okay. So now, once you have that same basis, we can equate the exponents, i.e. make the exponents equal. In this case, step 3 would be solve for x. But in this case, step 2 and 3 are the same thing, because once you have the same base, you guys like saying we cancel the bases. I don't like that, but we cancel the bases. Then your x has to be equal to 3. Okay, that was a bit of a simpler one. Now I'm going to do another simple one, because as I said, the ones where we're going down there is not going to be simple. Now, if I say to you, 3 to the exponent of x minus 4 is equal to 81. We drop the bases like they're hot, like hot potatoes. It's none of the laws, Lwandle. You're going to have to rewatch this lesson. You guys are laughing. Is it my dancing? Or is it Nelissa's comment? I'm going to assume it's Nelissa's comment because, yeah, I drink too much coffee, guys. See what it does to your brain. Okay, Okay, so first thing, we want the same base, which is going to be 3 in this case, right? Our base is going to be 3. Now tell me, how can I rewrite 81 as something with a base of 3? Yes, Tammy. Simologo is like we are over here. See where the purple is? Where all those arrows are? There we are. So we want to write 81, rewrite 81 with a base of 3. So on the left, we're going to keep our 3 to the exponent of x minus 4 equals. So you said 81 is the same as 3 to the exponent of 4. And then we said, drop it like it's hot, drop it like it's hot. Woo. Anyway, so we're going to drop the 3's because we have the same bases on both sides. Once you do that, you say x minus 4, i.e., for anyone who's lost about where I just got that, exponent on the left equals exponent on the right. Okay, so x minus 4 equals 4. Then you solve for x. So how do we solve for x? Get rid of this negative 4. If you get rid of a negative 4, it becomes a what? Plus 4 becomes a positive 4. Therefore, x will be equal to 8. Everybody who was lost, are you with me? Are we with me? I need to check in, guys, to make sure. Woo! Fulafella understands. Fulafella wants us to sing Drop It Like It's Hot. I see you. I see the vision. Okay. Jackie, when did you just, I feel like you just got here. Guys, if you just got here, we cannot start from the beginning. But you can rewatch this lesson. Okay. We're recording it and it will be on the website. Okay, now that everybody who was lost has been found, let us move on to more interesting ones. And then my pace doesn't want to go down because I'm trying to be mysterious. Okay, let's do D together. Give me ideas. No, come on, it's not that deep. It's not that bad. Okay, let's hear Shakira. Shakira? What does Shakira have to say to us? Shakira is not unmuting. Shakira is like, I didn't sign up for this. No? Okay, that's fine. That's fine. Whoever's laughing, I'm watching reactions. Okay, that's fine. Jonathan, are we helping me here? Yes, it has to be the same base. Who said they want to try? Okay, let's first hear if Jonathan wants to try. Hello. You want to try?
Hello? Can you hear me? Oh,
Yes, Jonathan, I can hear you.
oh, okay. So like, what you must do is like, you convert the 27 to 3 to the power of 3, and the 9, 3 to the power of 2.
I'm dancing. Don't worry, I'm not having a seizure. That was a happy dance. So 9 is going to be 3 squared, and we still have our x minus 3 outside. Okay? Equals 27, you said it's 3 cubed, and the x plus 1. Beautiful, Jonathan. Now what?
So like now, would you
Think of
like
your
only
laws of
like
exponents.
pardon?
Think of your laws of exponents. Remember when you have a power to a power, what happens to them?
A power
Unless
to a
you have a
power.
different idea.
What I was thinking, like you can say 2 times x, which will equal 2x minus 3, and then 3 times x equals 3x minus plus 1. Would that
Okay,
work?
you're not gonna multiply them, but you have to multiply them as a bracket. Do you see that?
Yes, yes, I do.
So this 2x, you have to multiply with the whole bracket, and this 3, you have to multiply with the whole bracket. And you're gonna use the distributive law to do that. Do you remember that?
Yeah.
Then let's do that. Tell me what to write, Jonathan.
So would it be x minus 3 equals x plus 1, and then you transfer the x to one side and the minus 3 to the other side, which will turn to a plus 3.
Okay, watch this, Jonathan. We still have a 2 there, right? So let's make our exponents equal. We still have a 2 times x minus 3 equals 3 times x plus 1. Remember, there were original exponents there. So we have to multiply them in. So you have to distribute this 2. So you have to say 2 times x and 2 times negative
2x.
3. And then you have to go, there we go, 2x minus
Minus 6.
minus 6 equals 3 times x
3, which is 3x plus 3.
plus 3. Beautiful. Now we do the whole solving for x. You said I take the x to the,
I take the like terms 2x and 3x on one side, and then I'll take the minus 6 on the other side, which will turn to a plus 6.
plus 6. And this 3x will become what?
It will become a minus 3, minus 3x.
Minus 3x. Beautiful, Jonathan. What's 2x minus 3x?
Negative 1x.
Negative x. And then what's 3 plus 6?
9.
9. Are we done?
No, we're not.
We have to get rid of
The negative.
the negative. How do we do that?
And the x must be by itself.
Exactly. So how do we get rid of the negative?
So do we divide it by 1?
By negative 1. But what you do on the left,
negative.
you do on the,
Right.
so your final answer is, therefore, x is equal to, what's 9 divided by negative 1?
Negative 9.
Negative 9. Beautiful, Jonathan. Major shout out. I love it. Thank you so much. Whew. Yo, guys, that was beautiful. That was beautiful, and my heart is satisfied and happy. Now let's go to another one that's interesting, because I enjoy doing that to you guys, right? Nzako's hand is up. Nzako, are you gonna do one with me, or did you have a question?
I have a question, ma'am.
Mm-hmm.
Oh, hi, by the way.
Hello.
I was with you, right, until we started dividing negative x over negative 1. So I don't know how we got to negative x and negative 1 equals to 9 over negative 1.
Okay, we minus 2 from 3. I mean 3 from 2. 2 minus 3 is negative 1. Do you agree?
Mm-hmm.
So we said 2x minus 3x, and we got negative 1x. I just didn't write the 1. So we got negative 1x equals, then we said 3 plus 6, and we got a 9. But we are solving for x. We are not solving for negative x.
Oh,
So
okay.
the only way to get rid of this negative 1 times x is to divide by negative 1. Then these will cancel. But what you do on the left, you could have to go and do on the right hand side. So this side, you'll have your x, which is what we wanted, equals a positive and a negative give you what?
A positive and negative.
negative, and then 9 divided by 1 is
9.
9. Do you see how we got there?
Okay, thank you, ma'am.
You're welcome. Okay. Okay, are we ready? Are we ready? Okay, let's do number E. Let's talk about number E, guys. We'll have a brain break after this, but let's talk about number E. Who is doing number E with me? Guys, please participate so that we avoid me singing because it's not working out. Tammy?
Hi, ma'am.
You're doing it with me.
Yes, ma'am.
What base are we?
Ma'am, isn't the base supposed to be 1?
How are you gonna make 5 to the base of 1? That's difficult. You see that?
Yes.
We have to use the base of 5 because we cannot change 5. It has to be 5. So x plus 3. Now, let's go back to our laws of exponents, guys. Think of the summary I showed you. What do you guys think we're going to do with this? How can we possibly rewrite 1? There we go. You guys already said it in the chat. Like I was still getting there. Oh yes, Witumelo, please remind me what the question was. Please, I said believe. Yes, so we can rewrite 1 as 5 to the exponent of 0 because anything to the exponent of 0 is 1. You guys are brilliant. Now we have our same bases, so we can drop the base like it's hot. Then we have x plus 3 equals 0. Transpose of 3, therefore x is... I can't believe this. I can't even trick you guys. You guys are like decades ahead of me. You guys are like, dang! And I'm still over here. Wait, Tumela, please raise your hand so I can answer you quick. I forgot your question now. I feel so bad. Sure. Okay, Witumelo, when your question is there, I shall answer it. Okay? For now, while Witumelo's typing, yo, guys, this brain break nearly killed us in the other class, and we still haven't figured it out. Let's see if we can figure it out here. Okay, let's start with our joke. What does our joke say? Why did the student wear glasses in math class? To improve division. Like the vision, but division. Okay, it's really lame, I know. I found it hilarious the first time I heard it. So I'm definitely gonna. Can we put 2 sides next to each other? Do you mean if it's like 3 minus negative 1? Is that what you mean, Vitumelo? Bogang is laughing. Justin is like, the joke is not for me. Kill vibe. I get it because I also can't see. Well, right. I also had lessons, guys. See, is to improve division. Oh, the way I said it was funny. I know, it's a little bit of a character. I know. Justin, don't be sad. Come on now. Witumelo. Hello. May I unmute? Hello.
I wanted to ask if we could put 2 signs next to each other, like maybe I'm saying 3 plus negative 3. Is it possible?
Yes, it is, but you have to resolve these two, okay? Okay, this is not an integers class, but I'm going to help you quickly. So this positive and negative, what do a positive and negative give you?
It'll give me a negative.
A negative. So then you have 3 minus 3, and that'll give you 0. You see?
Oh, okay, thank you.
You're welcome. Okay, guys. Guys, please tell me we're still not figuring this out. Do you know how long we stood at this in the other class? I'm not willing to lose that much time. Amira says 40 plus 40 times 2. The lemons have to be the same. The lemons have to be the same. Okay, what did we get for the lemons, guys? Whoever has figured this out. Minenhla's hand went up, so I'm inclined to believe Minenhla has figured this out.
Ma'am, I have like a question, ma'am.
Oh, okay.
So, ma'am, the grapes, ma'am, if it looks like bigger, that means it's times 2, ma'am.
It's 2 of them, yes. So the one that's here is 2 of them. This one.
And so also the blueberries are also times 2 if they look like many of the blueberries, ma'am.
Yes. Because it's 1, 2, 3, 4, 5, 6. So that would be times 1 and that'd be times 2.
Yes, ma'am. Sorry,
You look
ma'am.
like you have a way forward with this. Guys, I tried to figure this out and just like Charmaine Uti spiritual side eye. How deep is that? Lemon is 10. Spiritual side eye, even you. You guys are so deep. Okay, let's see. 10. Minus this, it'll be 100. Okay. So 100 is equal to something times. So the grapes are 5. Is that what we are saying? Is that what we are saying? Before I move on, guys, give me a way forward in the chat. Are you guys telling me what I just wrote right now? So 5 plus 5 is 10 times 10 years. Okay, if that's what you guys are saying, ne? So everywhere where I see a lemon, I must write 10, 10, 10,
Ma'am,
10. Yebo?
I'm still laughing at the spiritual side eye. It's just so funny.
Oh my gosh. Like the judgment that came from that. I see you, Shami, with your spiritual Sarah. Oh, okay. What's gonna happen now? Okay, we have 5, 10, 15 grapes. Ne? So it has to be 53 minus 15, which is, and then my brain was like, I'm tapping out. 53 minus 10 is 43, minus 5 is 38. So then, double the blueberries is 38. So one of them has to be, is it 19? Let's see if that works. 38, 38. Hi, but guys, this looks too big. What's 38 times 20? 2 lemons equals 15. 1 lemon equals 30. No, but that's not how it works. Unless you want to say 1 lemon is 15 and 2 lemons is 30. Because blueberry equals 11. Langmorsache, guys. Do you know what that means? Whew. Hi, Shem. Okay, guys, we're gonna start here next in the next lesson. Take the screenshots so you guys can go figure it out. Because now we are finishing my lesson time trying to figure out ama blueberry nama smoothie la. Okay. Yo, I don't even know how to explain what morsach is. Yes, you are destroying me. You are destroying me. That's what it means. Okay, guys. Take a screenshot. I want to move on with my lesson. Whoever laughed at me, I'm watching you. I saw you guys. I saw you. Okay, guys, we're gonna start here in the next lesson. And you guys, yeah, you'll let me know what the answer is because I'm definitely not gonna figure it out. Okay, why am I going up? We are moving on to more interesting things in life. Okay, nobody freak out. Everybody take a deep breath. You are fine. No dropping your IGs. No dropping IG or I will scream. Okay. That's Justin. Nobody panic. Everyone, back to me. Focus back on me. Come on. Okay. Listen, we can do this. We can do this, okay? Remember, when you solve for x, you get rid of everything that's around the x. Now let's do it so that I can show you that you can do it. Okay, someone raised their hand and I have a feeling they're gonna help me answer this. Jonathan, is that you?
Yes.
You're gonna
Hello?
help me?
Hello.
We can hear you, Jonathan.
What I think, like, the dot, isn't it, means times, so you're gonna say 2 times 8, which is gonna be 16.
No, you cannot times the basis when you have an exponent that is unknown, okay? Remember
Okay.
BODMAS or BEDMAS in this case, exponents come before multiplication, you see? So we
Yes.
can't do it, but we can just get rid of everything that's around x. So let's do that. We know how to do that, don't we?
Yeah.
Okay, so let's leave this times for now. Let's leave this times for now, 8x plus 1. How do we get rid of this 15? Negative 15.
We can work with negative 15 equals 1.
No, how do we get rid of it? Remember, x is on the left-hand side, né? Now we want to
Yeah.
chase everything and everyone away. So we can chase this 15 away to the right-hand side. What happens when it gets to the right-hand side?
It turns to a plus 15.
Certainly, plus 15, sorry. So we're gonna have 2 times 8x plus 1 equals 16. Guys, do you see already it looks better, Mark? Do you see that, Jonathan? Looks better
Yeah.
already, ne?
Yeah.
What can we get rid of?
Like, can't we like say 2 times 8 and then we have the same basis, and then
No. Remember I said you cannot, we are not allowed to multiply the bases, guys. What does
Oh.
BEDMAS say? Bracket exponents. So we would first have to figure out the exponents before we multiply what's in front. So you cannot do that. What you can do is get rid of this over here. How? Think carefully. If we are multiplying the 2, how can we get rid of it? Thank you. Divide both sides by 2. So we're going to divide this side by 2 and divide that side by 2. These two dudes are going to cancel out, and then you're going to be left with 8 to the exponent of x plus 1 is equal to 8 divided by 2 is 16 divided by 2, excuse me. 16 divided by 2 is 8. Check what happened there. What do we have now?
Oh, we have the same basis.
We have the same basis. So what can we do to the exponents?
So now we can work with the exponents. So like so basically, if there's like 8 is by itself, we would just like say in like our heads, we say 8 to the power of 1 basically.
Yes.
So it would so the plus 1 would go to the right hand side, and it would turn to a minus. So
minus 1. So how much is x?
1.
Remember, we had a 1 on the side, and this went over and became minus 1. So what's 1 minus 1?
You can have an answer as 0.
Yes, you can.
Yo, that's my first time seeing that.
X can be 0, okay?
Okay.
Don't be confused. X can be 0. We are solving for x. You just follow your rules. Don't overthink it. If you take the 1 over and you end up with 1 minus 1, then x indeed is 0. Okay. I know this one was a little bit tedious, guys. Nobuche says I'm lost. Nobuche, follow with me now. Okay. So we said we want to get rid of everything to get x on its own on the right. Okay? So now we have x, 8 to the x plus 1 minus 15, and that same thing is times by 2. So I said to you, get rid of everything around the x, right? Let's do that. Rabetwe, listen. Okay, guys, let's not congregate in the chat and say I'm lost. Let's listen. Okay. So we are saying, maybe I should rewrite it on the side here. So it was 2 times 8x plus 1 minus 15 equals, what does it equal to? Can't remember. Bad memory, equals 1. Okay. So I said to you, we want our x. Which number is attached to the x here? Let me know in the chat which number is attached to the x. The 8. Thank you, Rabetwe. I like when you're participating so that you understand this, right? The 8 is attached to the x. So we want to get rid of everyone around that so that we are left with just x. Okay. Now, step 1, you get rid of this minus 15. Now, if you want to get rid of this minus 15, it means you have to transpose it. But if you transpose it, it becomes a what? Becomes, bye, Amila. Guys, if you want to go, then you may. Please run the poll. Nelisa, if you want to stay, you may. Rabetsu, that's correct. It becomes a positive. Okay. So if you transpose it, it becomes a positive. Take note, on the left, I just rewrote everything the way it is. Okay. I just rewrote 2 times 8 to the exponent of x plus 1 equals. On the right, we had a 1. We just moved out 15. So it's plus 50. Okay, then we solve it. So it's gonna 2 times 8 plus 1. 1 plus 15 gives you how much? Tomoloho, that is moving it to the other side. So you're doing the inverse operation to get rid of it. Okay? 16. Thank you very much. Guys, I can't answer questions while I do this. Let me just finish it. Okay? Now we have gotten rid of the 15. But we still have one more thing on the left that is bothering me. What is that thing that we still have to get rid of? Guys, tell me. We said the x is attached to the 8. So what else do we, thank you, Rabetwe. We want to get rid of the 2. And the 2 is being multiplied. Do you see this dot here? This dot means 2 times 8 plus blah, 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 blah. So if I'm getting rid of the 2, how would I get rid of that 2? We are multiplying it there. How do you get rid of multiply? Divide by 2 on both sides. Right? That's where you are getting this. Okay. When you divide by 2 on the left, these 2 will cancel out. So on the left, you'll be left with 8 to the exponent of x plus 1 equals 16 divided by 2 is 8. Then we are back to the equations that we were working with. Do you guys understand? Now we have 8 on both sides. So we have base of 8, base of 8. If there is no exponent there, tell me in the chat. See, if there's no exponent, what's the exponent? Thank you, Tiamo. There's no exponent, the exponent is a 1. We have same bases, we are allowed to equate the exponents. So you can say, drop it like it's hot, goodbye 8, x plus 1 equals 1. Then we solve for x, because from here on, therefore x will be 1 minus 1, and that's how we ended up with therefore x equals 0. People that were lost, I hope I have found you. And thank you very much for being in this lesson. I love being here with you guys. I'll see you on Thursday.